Hello friends, welcome to Wiki Lectures. In this video we are discussing the question number 37 and 38 from Physics Kset question paper 2018.
The product of uncertainties delta x and delta px for the ground state of one-dimensional harmonic oscillator. One-dimensional harmonic oscillator, you need the product of delta x into delta px. Now delta x for any state, not only ground state, any state where n is the state, n represent the state. Delta x is given by under root h cross by 2m omega into 2n plus 1. Delta px is equal to under root h cross omega by 2 into 2n plus 1. Now you multiply these both. What you are getting is m omega gets cancelled, right? H cross by 2 will remain into 2n plus 1. Now you remove this 2n plus 1 here, h cross into n plus half. Now the question is for ground state. Ground state means n equal to 0. First excited state means n equal to 1. So for n equal to 0, your delta x into delta px value is equal to h cross by 2. This is for any state. For first excited state, it would be delta x into delta px. For first excited state would be equal to, then n equal to 1, so that would be equal to 3 by 2 h cross. Okay, so for ground state it is h cross by 2. So your option is B.
If the bore radius is a0, the most probable value of r in the ground state psi is equal to 1 by root of pi a0 cube into e to the power minus r divided by a0 of a hydrogen atom. Now what we know is the radial probable density. Density, which we can represent it by P of r, is equal to psi of r whole square times 4 pi r square. So this is the radial probability density. Now we can substitute what is psi. The wave function psi is equal to 1 divided by root of pi a0 cube e to the power minus r divided by a0. So substituting this psi of r into the equation 1, let's call this as equation 2. Then P of r is equal to 1 divided by pi a0 cube e to the power minus 2r divided by a0 into 4 pi r square. So let's rewrite that. 4 divided by pi and pi we can cancel out. a0 cube, then r square e to the power minus 2r divided by a0. So this is P of r. So now we have the probability density P of r equal to 4 by a0 cube r square e to the power minus 2r divided by a0. Now to calculate most probable value of r, so now we need most probable value for R. So to have this, we have to maximize P of R. So to maximize this, we need to differentiate P of R with respect to R and equate to 0. So which means all these quantities on the right hand side, these quantities are constant. So the d by dt, or sorry, d by dr of r square e to the power minus 2r divided by a naught equal to 0. So you using the product rule, differentiation of r square, that is 2r into e to the power minus 2r divided by a naught, plus r square into differentiation of what is in the next u. So e to the power minus 2r divided by a naught into minus 2 divided by a naught equal to 0. So let's take common out. So 2 into e to the power minus 2r divided by a naught, let this be the constant, the common. Then we have r minus 2 is there, r square divided by a naught equal to 0. So from this, r minus r square divided by a naught equal to 0, which implies r equal to r square divided by a naught. So from here we have r here, r is equal to a naught. So the most probable value of R in the ground state of hydrogen atom is option A